Characteristics of quadratic functions. A parabola is the curve of a quadratic function. The vertex of a parabola is the highest or lowest point. The minimum of a function is the least possible value, while the maximum is the greatest possible value. The zeros of a function are the values of x that make the function equal to 0. Other names for zeros of a function are x-intercepts, solutions, and roots. An axis of symmetry is a line that divides a figure or a graph into two mirror image halves. Here we have two parabolas that are graphed. We're asked to give the coordinates of the vertex, give the minimum or maximum value, and then state the domain and range. In example A, we have a minimum value. Coordinates of the vertex are 0, -4. The minimum value is the y value of the vertex, -4. The domain, because the curve extends forever towards the left and forever towards the right, it's heading in both directions, and there's no x value that's excluded, the domain is all real numbers. Now for the range, you can see that this curve will never fall below -4, so the range is y is greater than or equal to -4. Here's our vertex in example B. The coordinates are 2, 5. It is a maximum value at 5. Again, the domain is all real numbers. It extends forever to the left and right. But the range, it will never go above 5. So the range is y is less than or equal to 5. Now we'll look at the zeros from a graph. The zeros, remember, are the x-intercepts. And so we've identified the x-intercepts here. And we can say that they are -1 and 3. Algebraically, you could check that the value of the function at -1 equals 0, and f of 3 also equals 0. So the quadratic function has two real roots because it crosses the x-axis in two places. Example B, the function only crosses the x-axis in one place, so it has one x-intercept of -2. Again, you could substitute -2 in place of x in the function. You would find out that f of -2 does equal 0. This quadratic function has one real root. In example C, the curve does not intersect the x-axis at all. There is no x-intercept. There is no x value that makes that equation equal to 0. And so it has no real roots. Finding the axis of symmetry using a graph. So the first thing we want to do in the parabola shown in part A is to identify the axis of symmetry. It is that vertical line that goes right through the vertex. We write the equations of vertical lines as x equals -4.5 in this case. In problem B, let's identify our axis of symmetry. It goes through the vertex. The coordinate of the vertex, if you look carefully at the way the scale is and the interval on the graph, is 1, -4. So the axis of symmetry is x equals 1. So that's how we find the axis of symmetry using a graph. We can also find the axis of symmetry using a formula if we don't have a graph and we only have an equation. If we have an equation of the form y equals ax squared plus bx plus c, then the x value of the vertex is -b over 2a. We don't ask you to memorize a lot of formulas in algebra, but this one is going to be important. And so the axis of symmetry will have the equation x equals -b over 2a. So here we have a couple of examples. We'll identify our A, B, and C. And we'll write the formula for the axis of symmetry, x equals negative b over 2a. We're substituting in our values, and we get an axis of symmetry equation, x equals negative 3. In example B, let's identify A, B, and C. Our formula is x equals negative b over 2a. That is the opposite of b over 2a. And so our equation for our axis of symmetry is x equals 3/4. Now, at this point, we have some practice problems for you to try. So you can look back at the examples we've given you and give a try for these practice problems.